Hi everyone, welcome to the second video of torsion. And then in this video I'll be covering Serret fernet formulae. That's a formula that we're gonna end up coming up in this video. Okay, now in the previous video we're able to define vector b, which is the binomial vector, and then we said b was u cross n, and then we also said that n is equals to what I wrote here, and then the uds is equals to that. Okay, so you're gonna make use of this, and then something that I did not cover, but I won't cover either, is the derivation of this part here. So here is like torsion. Let's represent torsion by this symbol here. This symbol is called Calc or tau sounds something, but it's written as something like this. So we're gonna represent torsion by tau, and then we say that tau is equals to the negative of the BDS dot is a dot product here, dot n, and then the BDS is given by negative d tau multiplied by the normal vector. Okay, now these are the two things that we are gonna focus on in this video. Okay, now one other thing, say, remember, when we want to use the right hand rule, noting that the vector u and b are mutually perpendicular, meaning that whichever this vector is perpendicular to both of the other vectors. Okay, and then let this vector here be u, and this vector be n, and let this vector here be b. Okay, so we have this 3D model. Okay, now we said that b is equals to u cross n. You can check that. You can just pause the video and check it out, like b, because check out if b is u cross n using your right hand rule. Okay, now when you check that, we're gonna define what is u and then what is n. Okay, now I'm just gonna copy this one, then write it here to as b is equals to u cross n, and both of these are vectors, and then allow me to say n vector n is equals to vector b cross vector u. Okay, and then let's define vector u from our diagram to be given as vector n cross vector b. Okay, I hope they're correct. Vector n is equals to, okay, wait, vector u is equals to n cross b, and vector n is equals to b cross u. Yeah, okay, they're correct. Okay, now note that we have the uds, we have the bds, but we don't have the nds. Okay, that's one of the things that I'm gonna do in this video. So our aim is to find the nds. Okay, so we're saying that we know that okay, let me write first. Okay, from here we see that n is equals to b cross u. So the NDS is a vector differentiation, so we're gonna use the product rule on these vectors, taking note that we are taking a cross product, meaning that we do not have to mess with our order. Okay, that is very important. Okay, so the NDS will be vector B cross du ds plus db ds cross vector u. Okay, now having that, we can now represent the uds by k multiplied by the normal vector, and represent the bds by negative torque multiplied by the normal vector. Okay, let's do that, and then that will be equals to the NDS will be equals to vector B cross, just so it's gonna fit, vector B cross the UDS is given as K N, and then plus the VDS is given as negative tau multiplied by N multiplied by vector U. Okay, now check this out. K is a scalar, tau is also a scalar. Now we're taking a cross product of two vectors, and then one has a scalar, meaning that we can take out the scalar to multiply the whole cross product. So this, when we have to check this out, the order of this cross product, considering B and N, considering that too, considering B here and this N here, when we have to consider that, we are aware that in this formula we have N cross B, not B cross N, meaning that this will have to be negative U. Okay, so this is gonna be is equals to negative U, but note that we still have our scalar here, kappa. Okay, and now considering this N here cross U, and then coming here we have U cross N, not N cross U. So that means B will also have a negative binomial vector. But when we are to have a negative binomial vector here, that negative will counteract with this negative, will multiply with this negative to make it a positive. So we're gonna have a positive tau multiplied by vector B. These are vectors. Okay, to write it clearly, we say that dn ds is equals to negative k multiplied by vector u plus tau multiplied by vector b. Okay, so this is what the n ds is. Okay, now we're going to Serret fernet formulae. Okay, so with Serret fernet formulae, we have remember that we have u n b, and these are vectors. So say that u represent our I, and then n represent our j, where binomial vector represents our k. Okay, and then if you are to put these things like what we defined here, if you are to write with Serret formula, our aim is to write the UDS, the BDS, and the NDS in a matrix form. Okay, so I'm gonna do that. Okay, and I'm gonna write it in this way. I'm gonna say D over ds of, okay, we have U and B. Okay, note that this is the U over the S, and then the N over the S, and then the B over the S. Okay, and so we say that this is equals to, okay, we have this thing here. With, say, we're first gonna work with the UDS. Looking here, we know that the UDS is K multiplied by N. Okay, now let's just say that we gonna, in this matrix here, we're just gonna take the coefficients of our vectors. So here we have the coefficient of N, and we said that let N be the jth column. Okay, so we're gonna take the coefficient of N and put it on the jth column. So let it be in the middle, because we know that the jth column is the middle column in a 3 by 3 matrix. Okay, and then we also have the N, the S. So checking this out, U, we have the NDS, we have negative U plus tau B. Okay, it's negative U. We said that U is the ith column, so that means we're gonna have a negative K here. Remember, we also have this portion here of tau times binomial vector. We also said that the binomial vector will be representing our kth column, so we're gonna put it here as tau. Okay, and now the last one, the BDS, we defined it to be negative tau multiplied by N, and represent our jth column, so we're gonna have a negative tau here. Okay, we have this thing here. Note that we can write this matrix because it's a 3 by 3 matrix, so we can definitely put zeros here. Can just put zeros, 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 zeros. Okay, and now we multiply this matrix here by U, N, and B. Okay, note that, yeah, so from this matrix, this is what you get. Note that if we want, say for example, assume you don't know what is the UDS or the NDS, say we want du over the S. Du over the S will be given by, we're gonna multiply this row by this column. Okay, by the corresponding column. So note that if you are to multiply 0 by U, you're gonna get 0, and then K by this thing here, normal vector, you're gonna get K N. Okay, and that's how it works. You just, if you want the NDS, you're gonna multiply this row and this column. So that's it. That's all that you have to do when working with this form. Okay, and then I think that was it for this video, and then from now on I'll be covering tutorials that I haven't covered in this chapter. Okay, thank you for watching. Enjoy your day.